The IBM Engineering Lifecycle Management Suite, ELM, is a complete set of tools to support your system's engineering journey. ELM consists of a suite of applications that allow design teams to manage, develop, control and deliver design data on one single platform. IBM ELM includes 3 standard applications to support requirements management, test management, workflow and change management. Starting with IBM Engineering Requirements Management, DOORS Next. DOORS Next provides the capability needed to capture, develop and manage your requirements. IBM Engineering Test Management, ETM, allows your validation teams to manage, create, edit, review and approve test plans, cases and scripts that are linked directly to design requirements, architecture and work items. And finally, Engineering Workflow Management, EWM, for managing work effort across the life cycle, such as design change, day-to-day tasks, defects, issues, and risk management. The JAS platform uses OSLC, or Open Services for Lifecycle Collaboration. This open standard was originally developed by IBM and defines what a requirement, test, or work item consists of from a data perspective. The OSLC standard allows the JAS platform of tools to integrate with any tool that uses the OSLC standard. This means that even if you are not using IBM tools to deliver your test or task management capabilities, you can still integrate your DOORS requirements to other tools that can use OSLC. Let's have a look at the EWM application. The EWM application allows design teams to create plans that capture the effort needed to deliver the project. The main landing page for the project is the project dashboard. It is configured and administered by a user who has been assigned the project administrator role. Here we can see the project dashboard, which is made up of tabs and widgets that display metrics based on the plans, iterations, and work items that have been created as part of the project. Information shown on the widgets is live. Clicking on a link will allow the user to drill down into the detail. Hovering over a link will open a pop-up window with a summary of the data at the end of the link. Each user also has a personal dashboard that can be accessed from the user profile menu at the top right of the user interface. Dashboards can be quickly and easily customized by clicking on the Add Widget link. The layout of the tabs can be altered to suit the data being displayed. The dashboarding capability is the same for each application, allowing organizations to build a professional and consistent view of project data. This view of the plan shows a work breakdown schedule, listing the work items needed to complete and reach the milestone. The view is grouped by iterations that have been created to break the delivery down into manageable chunks of work. We can see that the concept release milestone includes a number of different work items such as a business need and some child tasks and defects. Work items can be edited directly from the view. Any changes made are reflected instantly on the project and user dashboards. This ensures all stakeholders are kept up to date on project progress and are aware of any changes in work priorities. Plans can be viewed in different ways, allowing the project team to organize who will deliver work and when. Changing the way the plan is grouped to show work item owner gives a view of resourcing issues or bottlenecks, allowing work allocations to be balanced across the team. Views can be saved and customized views can be created if needed easily through the EWM interface by project administrators, without the need to invest in web developers. Changing the plan view allows the project team to view the work effort from different perspectives, such as a Kanban view which shows each work item against its current workflow stage. We can see that work items must follow the defined workflow. Our concept release plan included tasks to review our design requirements. So let's take a look at the IBM DOORS Next application. The IBM DOORS Next application provides design teams with a centralized location within the project area to store, create, manage, and deliver the requirements management effort needed for large and small projects alike. DOORS Next offers a simple, intuitive interface to perform requirements development, collaboration, and reviews. Here we can see the DOORS Next dashboard. The applications all share the same interface elements, making things easy for users to get to grips with the tools. The ribbon across the top of the screen includes menus specific to the application domain. Above these menus, we can see which project we are in, the component context menu to the left and the configuration context menu to the right. This project area is being used with configuration management enabled. Configuration management allows teams to develop requirements across multiple development streams and product variants. Tabs and widgets can be modified in the same way as the EWM application. This particular project has been configured to include tabs showing project status and planning, requirements analysis, validation, and my current work, showing data specific to the user who is logged in. Opening the Requirements Analysis tab gives us a view of requirements classifications, coverage, and traceability across the life cycle. The Life Cycle Traceability Report has been created using the IBM Engineering Insights application. This bolt-on application allows users to create visual representations of data across the life cycle. We can see requirement traceability from stakeholder requirement specification through system requirements to test cases and also defects and the parent milestone. These views are particularly useful in understanding the impact of change from anywhere within the product. For information about the IBM Engineering Insights application, contact the Optimise engineering team. Requirements data can be quickly and easily captured using the Doors Next interface. The pop-up window captures information about the requirement being created. The red asterisks indicate which data elements are required. You can also create modules from templates. Templates can contain predetermined heading structures, or guidance information, or even requirement artifacts. Once the module has been created, the Doors Next interface blends word processing capability and the data management elements of a spreadsheet. Much like in a Word document, headings are created to break the document down into sections. Data entry functions are performed through the menus or by using shortcut keys to speed up data entry. Information can be captured through diagrams, using the built-in diagram edit feature. From the pop-up, change the artifact format to diagram. The Properties panel on the right of the screen shows attribute, comment and links information. Diagram elements can be linked to other artifacts within Doors Next or to other data in applications. From the Create button, the Import option provides access to the import wizard that guides users through the process. Simply select the file. Tell the wizard where and how you want to import the data and hit Next. Keywords can be assigned at paragraph and sentence level. This identifies which parts of the document should be imported as requirements information. The import wizard analyzes the document and provides a report listing the number and type of each requirement that will be imported. Once the import is completed, the content of the document, including the heading structure and any comments, are recreated within the module. Creating links is a simple process. Here we can see on the left we have our stakeholder requirements, and on the right we have system requirements. In the Stakeholder Requirements module, we have selected a view that includes that satisfied by column that we will use to link to the system requirements. From the Edit icon, the user can choose the Add Link option. The pop-up provides different ways searching for requirements and allows for creation of new requirements if needed. The Doors Next interface provides different ways of creating links between data across the entire development lifecycle. The links created are bidirectional, so a corresponding satisfies link is created against the system requirement. Any changes are tracked within the Doors Next system and can be reviewed and revoked. The Doors Next interface also allows us to create links by dragging and dropping requirements from one module to the other. Both of these methods allow teams to easily develop and capture the design rationale. Within Doors Next, an artifact's history can be reviewed from the Action menu at the top right of the screen. Selecting the Open History link changes the view of the artifact. The Revision tab gives a view of the changes made over time, indicated above the content window. Any baselines that include the artifact are indicated by the blue icon. The Audit History view gives a more detailed view of who made the change, what was changed, and when the change was made. Following the links within the change record allows the user to drill down into the change. Changes are indicated by highlights and strike-throughs. From individual changes to change sets or even full baselines, a highly detailed view of the design history can be reviewed, assessed, and reported on. To view the revision or audit history of a single specific artifact, we open the artifact by clicking on either the ID or the name attribute. We can compare the current revision against the previous versions. The same depth of history is captured. This very granular recording of changes is essential to building a robust digital thread, ensuring project stakeholders can rely on the information presented to them. Restoring a previous revision is easily done by choosing the Restore option from the Action menu. Restoring an earlier version of the artifact will also be captured within the change log. Much like DAWs Next and EWM, the ETM project dashboard is made up from tabs and widgets that can be configured to suit the needs of the project. Our ETM dashboard has two tabs: Planning and Execution and My Test Work. The Test Planning and Execution tab has been configured to show information about test plans, test execution, and any issues around the test process. For example, identifying any test cases that validate a requirement, but are not in a test plan, and test cases that are not validating a requirement. ETM uses test plans to organize and plan the test effort. Test cases are used to capture the functionality or capabilities described within the design requirements. Test scripts define how the test will be performed by the tester. We also have a My Test Work tab that displays information specific to the user. Our validation process starts from the system requirements. Within our system's requirement specification, we have a view configured that shows which requirements are ready for testing. The view includes the validated by link. The view also includes the affected by and tracked by link columns. These links capture the relationships between requirements and work items, such as defects, design changes, or tasks. Clicking on the edit icon, we can create the link to the test artifact. From the pop-up window, we can link to an existing test artifact or create a new one. When creating a new artifact, we can also provide any additional data needed. The relationship between the test and requirements artifacts can also be created through the test reconciliation feature from within ETM. This allows validation engineers to check for any new requirements and generate the test cases at the same time. Following the link we have just created will take us through to ETM. The link takes us to the new test case we created. The information captured within the test artifact is determined through the Sections pane on the left of the screen. Sections can be added or removed as required, using the Manage Sections link in the pane. We want to add this new test case to our test plan. The Links pane on the right of the screen shows existing links as well as providing a method to add links. Opening the Requirement Collection link section from the left of the screen shows any requirement collections that are associated with the test plan. The Reconcile feature can be invoked by clicking on its icon on the right of the screen. ETM checks for any requirements that are not linked to a test case. The validation engineer can now select which requirements need to be reconciled with a new test case. A further pop-up window appears, allowing the engineer to assign any required data to the new test cases. Required data is indicated by the red asterisk. ETM completes the process, creates the new test cases, and includes the links back to the requirements. This process enables teams to ensure test coverage back to requirements. ETM allows test teams to capture risk assessments, entry and exit criteria, and at test plan and case level. The risk assessment section allows the validation engineering to capture the risk probability and impact, as well as defining any mitigation actions. Pre- and post-condition sections allow the test engineer to capture test prerequisites and post-test activities such as uninstall instructions or cleanup tasks. Any tasks can be formally captured using the Add and Create Quality Task icons. Tasks are then created within the EWM application as work items, where they can be added to iterations and included in the planning process. Once the test cases are created and fully defined, test scripts are added to document how the tests will be performed. Selecting the test script option from the navigation pane presents the test script section. From here we can add existing scripts or create new scripts if required. When creating a new test script, the interface allows the test engineer to assign attribute data and write the individual steps needed to complete the test. More than one test script can be added to a test case if required. Test effort can be managed through a predefined or customized workflow process. The interface also includes the formal review feature, meaning the entire development and approval process can be captured within the application. All changes to test artifacts are tracked and can be reviewed or exported for audit purposes. Earlier versions of the test artifact can be compared to and merged. The formal review process allows the team to collaborate with peers within the application through the project dashboard. ETM has powerful capabilities for delivering both manual and automated testing when integrated with third-party test engines. Here we can see the test cases and scripts being selected for manual test execution. A test execution record is generated for the test case. When generating a test execution record, the test engineer can select or create a test environment. Test environments allow test teams to run tests over different software and hardware configurations. Test case execution records can be accessed from the section pane on the left. The test engineer selects the execution to be performed and the summary screen is shown. The summary gives an overview of priority, last run result, and a description can also be added. Next, the test script to be performed is selected, and the test engineer can provide an estimation of the time expected to perform the test. To start the test, the green icon at the top right of the screen gives the various options available. Selecting the Run option starts the test and opens the test interface. The tester performs each step in the script, providing a pass, fail or defer result, using the icons. Comments, attachments and defects can be added to each step to capture the actual result. Any defects raised during the test process automatically capture the test details of the script and case, as well as link the defect back to the test script, case, plan and requirements artifacts. When creating the defect, the test engineer needs to assign the work item to one of the work item categories using the filed against attribute. The rest of the data capture is optional and can be modified as required, such as assigning the work item owner and providing an initial priority rating. At the bottom of the description section, the test engineer can enter details of what was observed during the testing, so those reviewing the defect or working to resolve the issue have all the information they need. If any of the required data has been missed, a warning will appear indicating what needs to be completed before the work item can be created. A link is provided to the new work item on the test step. The link created is only associated to the test step performed within the execution record. The remaining test steps can either be completed or deferred. Once all the steps have been completed, the Show Result link is enabled. Clicking on the link completes the test execution and opens the Result Details section, giving an overview of the test performed and the final result. Navigating back to the project dashboard shows the latest details, allowing teams access to gain valuable insight into development progress, design rationale and most importantly, the traceability relationships that have been created as part of the engineering process. From requirements, through test planning, test execution, and defect resolution, the entire development stream is captured, providing a full digital engineering thread. Project stakeholders can review the entire engineering process, gaining detailed insights into the value that engineering teams deliver when developing a new capability or delivering a full product release. Thank you for watching this demonstration. Our aim was to provide an overview of the capabilities of the IBM Engineering Lifecycle Management tools and show how they work together. If you would like to learn more about any aspect of the demonstration or the additional tools IBM offer that complement and extend the core capabilities of the Engineering Lifecycle Management suite, or to discuss how the IBM tools can be implemented and configured to support your specific business objectives, please contact the Optimise engineering team today.